Cheap and easy solar power without the need for an electrician or permit, simply plugging panels into the wall? Yep, that's possible with plug-in solar, a trend from Germany that is now making its way to the US and Canada. Sounds almost too good to be true, and that's exactly why whenever plug-in solar shows up somewhere, the myths show up right behind it. We Germans have been through it, so in this video, we'll break it down. What plug-in solar actually is, how it works, and what you need to know about safety. This is Phasenlage, let's get started. So, rooftop solar is great if you can afford it. Although prices have dropped, a typical installation in the US and Canada can still cost you between $20,000 and $50,000 before incentives. And with living costs up, that's a hard no for a lot of people right now. And if you're renting, you usually don't even have roof access. Plug-in solar can solve that problem by letting renters and homeowners alike place a few panels on a balcony, a garage, in the yard, or even their roof, and simply plug them into a normal outlet so power flows into their home. That means you pull less from the grid, reducing your monthly electricity bill. This could enable millions to benefit from solar power by spending just a few $100s and doing the installation themselves. Plug-in solar systems have been available in Europe since at least the early 2010s, and by now, most European countries have legalized them, usually letting you connect up to 800 watts to a normal outlet with little to no bureaucracy involved and without having to pay an electrician. In May last year, Utah picked up on the trend and passed legislation to let anyone connect plug-in systems with up to 1200 watts of output power. Several US states are considering similar rules, with bills introduced in Virginia, Vermont, New Hampshire, Massachusetts, Pennsylvania, Colorado, Illinois, California, and in a couple others. While Canadian politics still has to take concrete action, plug-in solar is definitely a topic of discussion there as well. Long story short, plug-in solar systems could become much more common in North America sooner than later. So, what is plug-in solar actually, and what is the key difference compared to a full-scale roof system? A plug-in solar system typically consists of 1 to 6 solar panels, and since currently mass-produced panels generate around 400 to 450 watts each, the maximum system power is somewhere between 2400 and 2700 watts peak. That is much smaller than a typical rooftop installation. Those range from 7,000 to 15,000 watts peak on single-family homes, which equals around 15 to 35 panels. Most states plan on allowing you to connect up to 1200 watts or 1.2 kilowatts per power meter, and the idea is for that to cover your baseline electricity consumption. That means your fridge, your Wi-Fi router, standby loads, and likely your laptop or workstation. Your washer, dryer, or air conditioning will likely benefit as well if you run them specifically when the sun shines bright. Now, one of the common misconceptions around plug-in solar is that you have to rewire your electrical panels so that some circuits run on a dedicated solar power source, just like with certain backup generator configurations. And thankfully, that is not the case, since plug-in solar systems use so-called grid-tie microinverters like this one. This is a model by Hoymeyers with up to 800 watts of output power, and most of the microinverters you get on the European market today look somewhat like this. It features 2 standard solar inputs called MC4 and a somewhat proprietary AC connector. This gets connected to an adapter cable that has a standard AC plug on its end. Once the microinverter is connected to the panels and the AC outlet, it synchronizes itself with the alternating voltage from the grid. Then it takes the DC power from the solar panels and converts it into AC, producing a slightly higher voltage then supplied from the outlet to allow current to flow back into the house. It does all of this using semiconductor magic, so no moving parts involved here aside from a safety relay. This slightly higher voltage produced by this grid synchronous generator is physically inviting your devices to use that power first, while the rest of the necessary power comes from the grid. For example, if you have the air conditioning running on a bright sunny day and your house consumes a total of 2000 watts, having 1200 watts of solar reduces what you draw from the grid and therefore what you have to pay for to just 800 watts. If your house just draws 1000 watts, you feed 200 watts back into the grid. This excess power is then consumed by the nearest load, say your neighbor's house or the traffic light in front of your house. If you get something in return for the kilowatt hours fed into the grid, highly depends on your utility provider. They may offer net metering, which means they deduct what you overproduced from what you consumed, reducing your bill even if the generated power wasn't consumed in your home at the time of production. This is the best case scenario for your wallet because 100% of what you generate goes back into your pocket, drastically reducing the time it takes for the plug-in system to pay for itself. However, different models are possible. You could either get a fraction of each kilowatt hour produced as a credit or simply no payment at all. Here in Germany, we are typically getting around 8 cents per kilowatt hour exported, while the average grid price is around 35 cents. If that's going to be the case for your installation, you will likely wait longer until your solar system pays itself off. But you can make up for that by by running energy-intensive loads like your washer or dryer during sunny hours, so to maximize your self-consumption. In any case, make sure to speak to your utility provider to learn what their rules are and if you already have the right electricity meter before buying anything. Because if not, your exports to the grid might be counted as import and jack up your bill instead of lowering it. What you need is a bidirectional meter that measures import and export separately. Now, looking at those open prongs on the inverter cable, you might rightfully ask, is this actually safe or can I get an electric shock from the plug once the solar panels are connected to the inverter? And the answer is yes, this is quite safe if you have a properly tested and certified model. Modern grid-tie microinverters feature a safety system called anti-islanding that constantly measures grid resistance, voltage, and frequency. Once you unplug the inverter, it stops production and disconnects its energized circuits from the output within milliseconds, making it safe to touch almost immediately. But this also means that a plug-in solar system does not offer backup power in case of a power outage. You even have to disconnect it when running a generator or power station because an inverter backfeeding can cause damage to them. While the inverter is usually a very safe part in the system, the state of your electrical wiring and where exactly you plug in the solar system is definitely something you want to look into. That is because having a plug-in solar system combined with other loads on the same breaker carries the real risk of overloading that circuit. In most cases, one breaker serves multiple outlets that are daisy-chained along a cable. A typical circuit in North America uses 14-gauge cable and is protected by a 15-amp breaker, so if you overload it by a few amps, it usually trips within an hour, stopping that cable from overheating and possibly causing a fire. If you add an electricity generator, like a solar system, to that circuit, you increase the circuit's capacity by what the generator can produce. So a 1200-watt system, which is 10 amps at 120 volts, will increase the maximum continuous current to 25 amps within that 15-amp circuit once the sun shines bright. That is already too much to safely run on a 14-gauge cable for longer, especially if it runs in insulated walls. But since breakers are usually designed to cut power if their rating is exceeded by 35% for over an hour, this puts the maximum current at 30 amps, at least temporarily, making the cable the weakest element in the circuit instead of the breaker. That in turn will make it a fire hazard. You might argue that the loads you have plugged in don't even draw that much power, but you also have to take into account electrical faults where the current is no longer limited by the normal functioning of the device, and a delayed breaker can make the difference between a little bit of white smoke and a full-blown house fire. To get to the point, a plug-in solar system should be connected to a circuit with as few outlets as possible, so that solar energy has to go through your electrical panel and another breaker to reach your devices. For example, if you have an outlet in your garden shed or a dedicated one in your garage that has its own breaker, those are great to plug in your little power plant. If in doubt, speak to your favorite electrician to make sure everything is safe. If they suggest installing a dedicated solar input, it's probably worth the money. All right, let's talk about panel placement. Just because we Germans like to call it Balkonkraftwerk, that does not mean that it needs to be put exactly there. We don't stick to that either. Generally, every place that A, has enough space for panels, B, can carry their weight, that's around 50 pounds per panel, and C, is exposed to the sun for most of the day, will do. That can also be your lawn, your shed, or even your roof. Just make sure to ask your local administration which one of these places might require a building permit to add solar to. And if you rent, speak to your landlord first. If your utility provider offers net metering or if you work from home, placing your panels facing south makes the most sense to get the most power during the day. If you want to maximize self-consumption and are usually out of the house during the day, an east-west installation where you position half the panels facing east and the other half facing west will get you the most solar power in the morning and in the afternoon. Now, I can already hear those with prior solar experience say that you can't do that because all panels need to be pointed in the same direction for it to be efficient, and that is true for systems where panels are wired in series and then connected to a single input inverter. But the microinverters used in plug-in solar systems typically have one input per panel and either optimize each panel separately or in groups of two, so you won't waste power in configurations like that. Usually, the datasheet of the inverter tells you which input belongs to which tracker, but a lot of modern microinverters feature one tracker per input. One more thing, the tilt angle. Basically, how steep the panel is leaning relative to the ground. As a simple rule of thumb, a good all-around range in most of the US and Canada is about 20 to 50 degrees. Closer to 30 degrees tends to favor summer production, while 40 to 50 degrees usually does better in the winter and helps snow slide off. So in colder, snowier areas, going steeper often makes more sense. You can mount panels flat, but that will drastically reduce production in fall, spring, and winter. Plus, if you have trees nearby, dirt will likely accumulate so that you need to clean your panels often. So what does a plug-in solar system actually cost when you buy it in the US right now? You can get plug-in suitable microinverters with 1200 watts of output power from EcoFlow and NAP, and both set you back around $300 US. Non-affiliated links are in the description. EcoFlow are the only ones currently offering a set with both the microinverter and 2 or 4 rigid panels, costing you $10.99 or $18.99 plus taxes and shipping. And right now, you can only order it to addresses in Utah. You can save a lot of money by bringing your own panels, ideally by finding a solar shop locally where they typically sell for $150 to $300, depending on make, model, and output power. If you are interested in that, let us know in the comments below and we will do another video in English covering all the technical details on how to correctly match the panel specs with the inverter. Since choosing the right mount highly depends on your situation, they are usually not included with sets like the one by EcoFlow. But panels used for plug-in solar and full-scale installations are alike, which makes finding mounts easy. Panels typically have more or less standardized 8mm mounting holes, and their frames are between 30 and 40 millimeters thick. So you can just ask a local solar installer if they can sell you mounting materials. There are also options available in online shops such as Amazon, where we found pillar mounts that can be used for wall or roof installations. Drilling-free stands are also available, say for your yard or carport. And of course, sets for your balcony's handrail. Mounts will cost you roughly $50 to $100 per panel, including MC4 extension cables to connect panels to the inverter. All in all, the whole endeavor will cost you roughly $1,300 to $2,300 before taxes if you go with EcoFlow, and $1,000 to $1,700 if you bring your own panels. I know that is certainly more than the few $100s I mentioned in the beginning, but once this gains traction, prices will drop significantly and more competition will hit the market. That's what happened here in Germany, and I'm sure it's going to happen in North America. For reference, a typical 800-watt solar set with everything that you need costs you roughly 400 euros around here. That is $470 US, including taxes. Also, I am aware that doing all of this by yourself can sound pretty complicated if you are not in tech, especially when it's explained by a fast-talking German, holla the wood fairy. But believe me, once you've gotten into the matter, this is pretty easy stuff and can get quite addicting. I actually like to call this Lego for adults because it's that easy once you've gotten the hang of it. Not to say that adults shouldn't play with actual Lego, that's absolutely valid. Whatever, you know what I mean. Anyway, I hope you enjoyed this video. Please like it if you did. If you have questions, comment them down below and we will try our best to answer them. Thank you for watching und auf Wiedersehen.